Hi there, this is another question from booklet number 1, Biological Molecules. This is question 10, again on enzymes. Okay, question 10. A student carried out an investigation into the mass of product formed in an enzyme-controlled reaction at 3 different temperatures. Okay, so we're measuring the mass of the product formed at 3 different temperatures. Only the temperature was different for each experiment. That means all the other variables must have been constant. The results are shown in the graph. So again, really important to start. We're looking at time on the x-axis, mass of product formed on the y-axis. So we know as the mass of the product increases, that means the mass of the substrate will be decreasing. Just to remind ourselves, we go from a substrate to a product with the enzyme acting as the biological catalyst. Okay, so if we're making more product, that means there must be less substrate. Okay, use your knowledge of enzymes to explain why the initial rate of reaction was highest at 55 degrees. It's a little bit tricky to see perhaps, but this one here says 55 degrees Celsius. Then there is 27 degrees Celsius, that's this line here at 27, and then the one at the top, this one here, is 37 degrees Celsius. So why was the initial rate of reaction highest at 55 degrees? Well, at 55 degrees, the molecules will have more kinetic energy. That means they're moving around more, moving around faster, and therefore it's more likely that they will collide. So the substrate and the enzyme are more likely to collide to form enzyme-substrate complexes. So at 55 degrees Celsius there will be more enzyme-substrate complexes forming in that initial period because they have their enzymes and the substrates have more kinetic energy and they are more likely to collide. Okay, but then if we have a look here, after 20 minutes, after this stage here, we can see that at 55 degrees, no more product is formed. We've reached the maximum mass of the product. Now the reason for that is 55 degrees Celsius is above the optimum temperature for an enzyme. But we need to go into a little bit more detail here. So we know that at 55 degrees Celsius, the hydrogen and or the ionic bonds will break. Okay, those hydrogen bonds are sensitive to increases in temperatures. They vibrate more when those hydrogen or ionic bonds break. That causes a change to the tertiary structure. So the tertiary structure changes, and those hydrogen ionic bonds hold that tertiary structure in shape. Part of the tertiary structure is the active site of the enzyme. So the active site also changes shape. Now, we know that the active sites are very specific and complementary to their substrate. So if the active site changes shape, it's no longer complementary to the substrate. So the active site no longer complementary to the substrate, and therefore no enzyme substrate complexes can form. Okay, so there are more than 3 marks that I've written here. Importantly though, we must state that at that higher temperature the hydrogen or ionic bonds break, causing a change to the shape of the tertiary structure. And then these last 3 bits that so the active site changes shape, or the active site is no longer complementary to the substrate, and therefore no enzyme substrate complexes can form. Okay, and then finally, explain why the curves for 27 and 37 level out at the same value. Okay, and if we have a look at the graph, you can see 37 levels out. Yeah, that's a 3.7. I think they level out at. Don't actually need to know that. And then, if you look at the 27 degrees Celsius, it's also 3.7. They level out at the same value. So they produce the same mass of product, 3.7 milligrams. Okay, so why do they level out at the same mass of the product formed? Well, given enough time, all of that substrate will be converted into product by the enzyme. And that's what's happened. So, we can say all substrate is converted to product, and therefore the same mass of product is formed. And the reason we get the same mass of product is, I'll just remind you at the beginning, only the temperature was different for each experiment. And that means the initial substrate concentration must have been the same. Okay, so at 27 degrees and at 37, so at 27 degrees and at 37 degrees, I have the same initial concentration of substrate. Okay, so 2 of those are points for the 2 marks. Okay, thank you very much.